Good morning, everyone. At the risk of a cliche, now for something well, at least slightly different. So I'm going to talk about something a bit closer to the start of the value chain, if you like. But I'm going to share some parallels with where Openphacts has come from as a former IMI project, moving into sustainability. We're about 18 months out on our own as the Openphacts Foundation. I'm going to talk about some background, some of which you may have seen before, some of which will hopefully be some familiar themes. Also acutely aware that I'm standing here between you guys and coffee, so I'll try not to waffle on. Leave some time for discussions at the end, because I wanted to try and pick up some themes, at least around sustainability and community and some of the other things we've been hearing here. And also start to think about how we, as we all come out of this IMI process and are out there kind of competing for money, competing for pre-competitive angles, I think how we can do possibly a lot better together rather than trying to do it all on its own. So, Openphacts really is bringing together pharmacological data resources in an integrated, interoperable infrastructure. That's a lot of a mouthful in there. But actually, we'll just take a step back a bit. So we're coming at things from kind of the early discovery end, where the data is probably even more chaotic. We still suffer from a lot of the metadata and context problems that Mike ably described earlier. But really, we were trying to think: why is it hard when you see a new publication that you might be interested in to actually go and find some of that data? At least from the drug discovery perspective, what's the target? What's the chemical structure? Have we got anything like that in the file? If you're a pharma company, can we make it? Is there any all sorts of information that you kind of go as this business as usual process that you do when you start in drug discovery projects? And actually, it's really quite hard to find that. And to pick up a theme that we've certainly heard already in our big data world, certainly a lot of folks with the pharma leadership and everyone else thinks, yeah, it's all big data, we just stick it all in a big container and everything's fine. Yet we know, that most of us data scientists, bioinformaticians, computational biologists, computational chemists are actually at this 80-20 rule, even if that's being generous, of trying to manually massage things and humping the boxes off the ship, trying to make some sense out of it. And I think I even pinched that very container from one of Mike's slides in a previous existence. But it talks to the point about why there aren't any standards in these spaces, or at least if the standards are there, they might not necessarily interoperate, and we're stuck very much in this moving boxes around manually. It was probably about, horrifyingly, 10 years ago so now. Several of us at that time, I was in Pfizer, as Jay said, and Mike was still at GSK, Nicholas was still at AstraZeneca. We were actually thinking, how do pharma companies use public data? And I just think, most people are using the same databases. They download it, put it behind the firewall, do some integration, and do some data analysis. And if you look across the industry, everyone is doing more or less the same thing with more or less the same data, more or less the same analytics, for more or less the same reason. I actually thought, if we just did this once, properly, openly, in the public domain, could we then actually use all of that resource to do something interesting instead of duplicative and actually get on with the day job of finding new drugs? Because we all know there's a productivity crisis, and the more we're just shuffling data around to no impact, the less time we have to do the really interesting stuff. And that's where Openphacts came from. We wanted to take a lot of this early data, put it in one place, integrate it in a single open and free access point, as well as start to think about making that sustainable in the long term. Because there's no point just doing this once. We need to reproduce it, we need to be able to do it in the long term, and if we're going to build an infrastructure that people use, we need to engage a community and not just have it disappear when the funding dries up, postdocs move on, someone turns off a box under a desk somewhere, and then your infrastructure's vaporised. So sustainability is really, really important for us. A bit more on the background for some of these things, and I apologise, this may be a little kind of chemistry for some folks, but why we were focusing on pharmacology data is we actually asked people across the pharma companies that were involved in Openphacts, what are the sort of questions you have? Why do you want to put all this data together in the first place? Because we could come up with something really interesting for us as data scientists to play with, but what are people actually trying to do? What are the questions they can't answer? And they tend to be fairly straightforward things like, what's the selectivity profile of a P38 inhibitor? Show me some chemistry stuff about these compounds. Find the compounds that inhibit targets in the NF-kappa B pathway. And when you look for, try to find all of these, you need to look across at least all of these sources. This is not meant to be an exhaustive list. This is a list of what we've integrated in Openphacts. But it's just an example of partly the duplication, but also the overlapping sources where you're going to go and find this. Our kind of yellowish ones over here, trying to put in a different colour, because there's data out there in the private domain as well. You might subscribe to some of these things from Thomson Reuters or whatever they've turned into now. The Chinese have bought them. Various other places that actually will sell you data, and you want to be able, your scientists at the bench, to be able to find that data now. So being able to do that in one place is really difficult. These are some of the questions. I'm not intending that anyone actually reads this. If you want to, you can go see the publication that we put out there. But actually, there's everything on this list from the fairly straightforward things to stuff like what is Alzheimer's at the bottom. We didn't really get very close to that necessarily in the course of 5 years of IMI project. But it shows the range of question and the range of, I guess, unknown, or at least the range of things that people are trying to apply this data to. And if you take this business question approach and say, what are people trying to do with this data? Why are they trying to put it in one place, and how we can support that can help you do some sensible analytics down the line. So, some more shameless plugs for publications. We actually built a platform. I'll talk a little more about this a little later on. It's production level, secure and private. Again, if we're asking people to do chemistry queries across the internet, it's all well and good putting your infrastructure in the cloud, but if you can't prove that that's private, we've run into problems. It's guided by the business question and uses semantic web technology, providing simple RESTful API for everyone else. So talk a bit more about why that's important as we go. But just some of the things that we were trying to do with this data, really to try and integrate all of these sources and build it into something that is, will allow you to answer some of those business questions with the appropriate queries. And you have to care about an awful lot of things. The and more at the bottom of this slide is deliberate. You've got to put all this stuff together. You've got to make sure that you've got all of these identifiers, the pharmacology data, and the physicochemical data, all of that stuff organised, integrated, and stable. But at the same time, there are three industries represented on this slide. Two of them don't have an argument about what things are called. Biomedical data, we are a nightmare. We're actually our own worst nightmare. Data generators are their own worst nightmare. If we could just stick to one thing, say, a drug is a drug, it's this URI, a target's a target, it's this target, it's this URI, yes, we'll talk about epigenetics and everything else, but we delight in pretending that things are a bit special and a bit different and a bit complicated, and we replicate that complication in every data source we can. So when you're trying to deal with that, put it back together and actually have a sensible discussion about what data there is, we made all sorts of problems. So we tackled it through actually not just developing standards, and this cartoon is massively overused. There are 14 standards. It's ridiculous. We need one that does all of them. Yes, now we've got 15. But I think if we actually put some weight behind it and actually use some of those, and which we actually did through the course of Openphacts, I'm not going to go into exhaustive details on this, but actually data set description is really, really important. Quantities, units, dimensions, and types. For us dealing with pharmacology data, largely ripped out of publications or driven from databases that take those out of publications, if you can't handle micromolar in all the various forms that it appears in the literature, it'll be really quite difficult. Provenance. Again, we actually built the entire system to leverage provenance here. There's no point just serving up data if you can't say where it's come from. And that sounds simple until you actually try and do that, which I know what you do with clinical data, and Matrix actually builds a lot of that in, but from our perspective, a lot of the public sources of pharmacology data don't do that very well, so we wanted to really take care of that, and not actually just kind of set the standard, actually use the standard, engage with the, in many cases, academic community that develop these standards, and rather than say, we need a special industry way of doing this, we're all in the same boat together. How can we move the standards to something that's more fit for purpose, and then contribute that back openly to the public domain, which is what we did. So we can't survive without one infrastructure diagram. For those in the room that know, I'm actually an old-fashioned biochemist, so this is all gibberish to me. So you don't want me talking about data in too much effort, but we take all the public ontologies, either from public or commercial content, turn it into RDF, use the data descriptions, try and index that. We go through chemistry registration and normalization. For us, chemistry structure is really important. The way the public domain handles those is ghastly, mangles them. So we have to make sure you haven't got a 7-membered benzene ring or some of the other entertainment stuff where you're trying to drug Buckminster Fullerene. That goes into a big data cache. We've got a semantic workflow engine over the top that does a lot of clever things actually at runtime. We put a lot of effort into identity resolution and identifier management. That's how we know that a thing is a thing. We're talking about the same drug, the same target, the same compound. And we put the API sits on top, and we feed data out into there. You will notice in the course of this that I'm not talking about an interface, and that is entirely deliberate. What we were trying to do was build kind of an ecosystem around this, and it actually says, if we take care of the boring stuff, you can then use the services and do the sexy stuff that you want to do at the end of the day. And we couldn't do both of those at the same time, so we actually have there's some stuff on here, expanding things into workflow tools like NIME and Pipeline Pilot. We've got various other different users in there, some people that build things into their proprietary chem tools that you can actually do. This is real chemistry on an iPad, not a picture of the chemistry on an iPad. That's important. It's kind of thinking that some of the things I heard about the discussion yesterday about data as oil and data as a currency. This is where we see that working. How we actually do this openly in the public domain in future is an interesting debate, because it's not traditionally monetizable. But it does show that you can have this kind of oil well or refinery or whatever you like. A lot of our stuff is on GitHub. You can go there, find it, download stuff, use the APIs. Importantly, what we're also thinking about, because not everyone in all the pharma companies is happy with squirting their chemistry queries out into the public domain, even though many of them are doing it with their email in the cloud, and that would arguably be less secure for me. But anyway, do you want to take out our stack, run it in your environment? We can Dockerize it, stick it behind the firewall, then you can do what you like. Add your own data. We can have a discussion about how you standardize your data, how you build those things together, and actually incorporate your own data along those services, which is, I think, is an important thing for us as we move on. And again, I talked a little bit about Pipeline Pilot and NIME. We recognise that most of our users are kind of traditional chemists or bioinformaticians. Not everyone wants a clicky Google interface where you just type something in and get a result out. You want to be able to build things into a more complex workflow. So from our perspective, it's much more maintainable to do that through the workflow tools that everyone's using than trying to build an interface that does that. So now you can plug this into NIME and Pipeline Pilot. People have visualizing data in Data Warrior. We want people to be able to use the tools wherever they are, just to get on and have stuff, and not be linked to an interface. So that's kind of the background then, and I think I tend to put this slide in quite often just because it raises a few questions as you start to think about these. But yeah, in a way we're coming out of IMI. It's almost like a reverse startup process. We go from this kind of theoretically lavishly funded 5-year project to something which is a startup. Which is completely different to where things have come from. So this is, for those that don't know, this is Professor Carol Goebel from the University of Manchester, who was part of the OpenPhacts project, part of various other things around the place as well. And, software is free, like puppies are free. They both need money for maintenance. You've got to keep them up, you've got to keep them running, you've got to develop it further, you've got to go and apologise to the neighbours when it kills chickens or whatever else it might do. So, part of what we want to sustain for is actually think, how do we keep what is there running? But also, we recognise that looking at pharmacology is only part of the value chain in pharma. We chose for our IMI project to run a deliberately bounded area, and recognise that what we've done here with the first really fit for purpose and scale semantic infrastructure to do this can go in several other different directions. So keeping things sustainable, open and free as we've seen. What we did was actually set up the Openphacts Foundation. In retrospect, we probably shouldn't have chosen the F word, because that means everyone thinks we've got millions from Bill Gates or someone else, rich American philanthropist. So the Openphacts Foundation is a UK-based non-profit member-owned charity. The reason it's in the UK is not because I'm British or lots of the other folks in British are involved. It's actually one of the few places you can set up this kind of non-profit entity with people from all over the planet. Non-profit status for us is important. We actually have in our aims things about educating the public in the use of data to find drug discovery tools, but it's also important for us. It keeps us honest and it helps us engage with the academic community as well. So we have this large infrastructure which you've seen before. And what we're really trying to do, and I've spent a lot of time over the last 18 months, is trying to work out how we can evolve that platform, as well as start to make it more robust and start to take things in different directions. So we kind of started here with our public data, which we talked about. We take public and commercial data. We actually ran pilots with some subscriber-only data from a couple of publishers to show that we can surface their content to subscribers, but more importantly, not surface it to people that haven't paid for it, which is certainly from their interest. We can take the public data in our kind of Docker container VM and actually stick that behind the firewall. We can work with people's private data if that's the way that they want to go. And it's all in a securely audited hosted platform. We don't track the logs, we don't see what people are taking. It's been properly audited by 2 different pharma companies with the way that they do this with CROs. I put this slide up with no intention that anyone actually goes through it, but we're actually starting to think about answering other questions that we didn't cover in the course of our IMI project. So this is around pathways. Of course, there's a lot of data in how there's a lot of interest in how biological entities are linked and how you can start to use that to explore druggable projects. It's very early days in this, but we've got lots of data that allow you to kind of move up and down, take care of some of the directionality things and surface some of that data in different ways. And also the Openphacts Foundation, as a UK registered charity, we're also able to participate. We do participate in the Horizon 2020 programmes, one which is Eurotox Risk, which is just starting. The one here on Big Data Europe, which actually looks at big data infrastructure right across the 7 societal challenges that are mapped to Horizon 2020. We're the healthcare exemplar. And actually, a lot of the work that we've done in Docker, I think is really quite interesting, because we're quite used to saying big data in healthcare. But if you think about big data in transport or big data in some of the other societal challenges, there are domains that still think Excel is a database. So it's really quite interesting to be able to share some of our experience in that. Platform, a project that's looking at building a kind of a big data generic platform that you should be able to use any sort of data you like. More recently, actually in the last month, we announced a strategic partnership between ourselves and Data to Discovery, which is a small startup in the US. This is actually David Wild, who's kind of a semantic chemistry expert at the University of Indiana, so it's his company. And what we're actually doing then is re-engineering part of our architecture, part of the platform, making it more stable and robust, and starting to think about how we can we've actually moved the tech stack onto Amazon, which was an interesting process, but we've proved that it's doable. And we're refreshing a lot of the data sources and simplifying the pipeline. I guess in common with you guys, I know there's been a lot of different platform releases. We get through the course of our 5-year IMI journey, you end up with a platform that has all sorts of interesting features, should we say. So robustifying that and allowing us to be clearer, faster on refresh, more current with data is really important to us, particularly as we move, as we said, from something like 120 FTEs, which we did have through the course of the project, down to less than 10. That kind of reverse startup journey is quite an interesting one, particularly when we start to think about relying on others to be, and the community to be able to generate some of the data and do some of the coding. So my message to you guys is come and collaborate. If you haven't heard of us before, then do come and have a discussion. Do come out and engage with us. There's all sorts of ways we can do, all sorts of things we can do, all sorts of ways that we can engage. And I just wanted to put a couple of questions up towards the end, just to try and think about, particularly this last one, what questions have you got for me for navigating the post-IMI experience, and what learnings can you guys take from that as you're about to embark on that? How can we cooperate, particularly, and also put some of the in the nicest possible way, put some of the pressure back on FPS, put their money where their mouths are, and really leverage the infrastructure and the assets that we've all built here. So that was my last slide for thank you to all the OpenPhacts partners. Questions?
Thanks, Bryn. Samuel from GSK. Just a question. What's the best published example there is where someone's extracted some knowledge from one of these graphs, fact validated, and made a difference in their business?
Yeah, so we have got some. Talk to Stefan Sanger, that will help you. And he has literally just published one in the last couple of weeks using some of the patent data from our platform.
I've got a question for you. So what you have set up as a foundation, how is the foundation staffed? For example, do you keep software developers on, or do you leverage partners to advance the infrastructure?
Yeah, so the easy answer is yes to all the above. So the Openphacts Foundation is mostly virtual, and it's kind of designed in a way to be always teetering on the edge of bankruptcy. Mostly to make sure that we're honest as a non-profit, but also in this space we're kind of almost at the mercy of some of the larger content providers thinking that we're trying to muscle in on their business model, which we're absolutely not. So we pay some developers, we pay some kind of fee-for-service contract stuff, but we also heavily rely on our community of data providers. A lot of folks have kind of cut their teeth on RDF through the course of this project, and actually how they've done that and how they continue to do that in the future. We are very, very dependent on our academic community, and I think as much as we can, we try to leverage that and also bring them into some of these other projects that we're involved in.
Because there's a lot of partners, and I assume these were the partners in the original Openphacts.
Yeah.
How many of those partners carried through into the sustainability chapter of the program?
Yeah, so that is a moving feast. So it's, I'd say roughly about half. And again, so, some of the big pharma companies, some of the academic partners, it's much more challenging to keep SMEs engaged because that is much more dependent on funding being there. So we try to engage on a project by project basis for those guys.
Hello, Martin Romaker, Bosch speaking. I would have two very short questions. One question is about drug bank and ChemSpider,
Yes.
which are no longer public. How does this impact your OpenPhacts project?
Yeah, so drug banks are an interesting one because even though they're kind of monetizing their license, they haven't refreshed their data for some time, and we are current with drug bank. They're not necessarily very current themselves. We're discussing with them how they really intend to run that license model going forward, so we're going to take that on advisement as it goes. ChemSpider, we're actually re-engineering the chemistry registration engine, which is going to be available soon, and that should form the cornerstone of something that would be quite a useful open asset for other projects, and we could have a discussion about that later. Your other question?
The second question is that, since you have started to work on OpenPhacts, I think that I have very much ramped up the capabilities in the RDF space as well, for example, with regards to Campbell and Cabby, which are still the main input sources to OpenPhacts. So how will this affect your project?
So actually it makes our jobs easier because it was mostly through their involvement with us that Campbell went down this route and did actually had to bite the bullet and do a lot of re-engineering of their data model because, again, biologists talking, I'm told there's nothing like RDF to show the flaws in all your original data schemas, and so we continue to engage with those guys. We're also working with them on how to bioannotate short Campbell and the patent data, how to recognise the entities in that. So we're still working on that one, Martin.
Thank you very much. I think we're exactly on time. I think next up is a break for 15 minutes.